Today, in our experiment, we will study the distribution of an alternating ultra-high frequency electric field in space. The main device is an ultra-high frequency electric field generator, with the help of which we are able to get a UHF field. As you can see here, if we connect these two electrodes to this device, we get a therapeutic circuit. After connecting the electrodes, we can use this installation for medical purposes. A UHF field occurs between these electrodes. And we can determine how this field is distributed in space by using a dipole antenna. A dipole antenna consists of two metal lugs separated by a dielectric. And as you can see here, these ears are connected to a microammeter using conductors. To make it easy to change the position of the dipole antenna, it is mounted on a moving ruler. At the beginning of the work, we need to install the dipole antenna in the center between the electrodes. And by reading the microammeter, we can measure the current that appears in the dipole antenna when it is placed in an ultra-high frequency electric field. After that, we must move the dipole antenna 1 centimeter from the center of the field and measure the current value on the microammeter. Thus, moving the antenna away from the center of the field every centimeter, we must record the readings of the microammeter. After that, we must enter the data into a table and use these values to build a dependence graph. When an ultra-high frequency alternating electric field acts on the tissues of a living organism, a thermal effect appears in the body, which means that the heat is released. And to study the effect of the UHF field on the body, today we're going to look at how the UHF field acts on electrolytes and dielectrics. We use an ordinary saline solution as the electrolyte and castor oil as the dielectric. First off, place a vessel with a saline solution, which is electrolyte, between the electrodes. We need to measure the initial temperature of the electrolyte before turning on the UHF generator. The initial temperature of the electrolyte is 22 degrees Celsius above zero. So at 0 minutes, the temperature is 22 degrees Celsius above zero. After we turn on the UHF generator, an electric field will appear between these electrodes and it will begin to affect the electrolyte. We need to wait for 3 minutes and then measure the temperature of the electrolyte. If the initial temperature of the brine was 22 degrees Celsius above zero, after 3 minutes, the temperature of the solution increased to 22.5 degrees Celsius above zero. In this way, we must repeat the procedure several times and enter the obtained value in the table. Now, instead of a saline solution, we put castor oil, which is a dielectric, in an ultra-frequency electric field. We need to measure the initial temperature of the dielectric with a thermometer, and you can see the temperature of 22 degrees Celsius above zero. Next, like with the electrolyte, we need to wait for 3 minutes and then we will measure the temperature of the dielectric. After 3 minutes of castor oil being in the UHF field, its temperature rose to 24 degrees Celsius above zero. We need to repeat this work several times, so every 3 minutes we measure the temperature of the dielectric and enter the data into the table. As a result of today's work, on the first table you must determine the distance of the dependence of the current strength in the dipole antenna from the center of the field between the electrodes and build a graph of the dependence. Also, according to the second table, you must plot the dependence of the temperatures of the electrolyte and dielectric on time. To compare two graphs, electrolyte and dielectric, You must draw on one coordinate axis, where you plot time on the horizontal axis and the temperatures of two liquids on the vertical axis. In your conclusion, you must explain the results which you obtained.